Welcome to my second video. In my previous video we covered voltage. In this video I'm going to cover current, resistance, and power. I'm only going to touch on power. In fact, this is just an introduction. We're going to cover voltage, current, resistance in greater detail when we hit Ohm's law. So current, the symbol is I. Once again, Europeans, the French, intensity. And its symbol is the A, and that's amps. Resistance, R. It is in ohms. Power, P, it's in watts, and its symbol is W. So like I said in my first video, when you apply a voltage across, we have a voltage, you develop an electrostatic field. So that's what happens, literally, when you put a battery across a conductor. An electrostatic field develops across that conductor, and it causes electrons to flow. It pulls the electrons, so the electrons are negative, they get pulled through the conductor to the positive terminal. So that's current flow. Now, the other property we have here is resistance. Everything, with the exception of superconductors, have a certain amount of resistance. Can't get away from it, and it is very useful. You couldn't have modern electronics without it. So what happens with resistance is, as this current is flowing through these electrons, they run into atoms, they interact with atoms. And just like if you would beat a nail with a hammer, beat it in, you don't take it all the way down, and right when you get through beating it, you touch it with your finger, you might burn your finger. Same thing's happening. The electrons decelerate when they interact with the atoms. They give up energy. The electrostatic field reaccelerates them. They interact again, and it gives off heat. And so let me demonstrate this. What I have right here is what's called nichrome wire, resistive wire. This is what you have in your hair dryer and your electric heater. It's wire that is specifically formulated to have a high resistance. So when you apply a voltage across a conductor, current flows. In this case we have 7.4 amps flowing across, and we have 10 volts. What you can learn a little bit later on is that if you multiply voltage times current, you get the power in watts. So this is roughly 75 watts of heat being given off by this wire. Another neat little thing you'll notice is that it sags. When I turn the current off, it pulls back together, it comes back up. When I apply power, it heats up and it sags. Conductors typically expand when they heat up. Most everything expands when it heats up. So that's one little interesting property, and just follow that back in the back of your head. Another interesting property, which we're going to cover when we do conductors and insulators, is that most conductors, not all, but most conductors, when they get hot, as they heat up, their resistance goes up. There's other ones that go down when they get hot, and there's certain alloys, magnetum I believe it's called. I got to look that up, but that is an alloy that they use in resistors so that they don't change their value of resistance as the temperature changes. A lot of precision instruments have that in it. Wonderful stuff. But we're going to come to my next video. My next video will be Ohm's law. I'm going to throw a little algebra in there, very little. The math and electricity and electronics is really easy. So don't ever be afraid in practice. Well, I'll see you in the next video. Thank you.